I'm a self-taught software engineer who works with TypeScript on a daily basis and React on the front end, NodeJS on the back end. In this video, I will explain the back-end architecture I use that's been bulletproof for me, the company I work for, and all the side projects that I have. We're going to be going through a little slideshow to demonstrate everything with examples. So let's get into it. First is the folder structure, and this video will be focused mainly on the API architecture, but I will go over the whole folder structure. So we have our API that will hold all of the controllers, interfaces, middlewares, and routes. Then we have a config folder, which will hold all the configuration, like your environment file, our database, as the name suggests, all of our database things, loaders, which would load all of the things that would need to be initialized for the app to run, like Kaiseli, Express, things of that nature. Our services, which would be all of the business logic that we have, subscribers, utility functions, and of course, our favorite app.ts, our entry point of the app. The TLDR of all of that is the server folder separates all concerns of the application lifecycle. So, lifecycle of the app, part 1. We start in our app.ts and we load everything that we need using our loaders. In this case, we just have the Express loader here. We initialize the app, we pass in the app to our loaders, and we just initialize our Express loader here. But expanding upon this, we could have a database loader, which would load all the configuration for our Postgres or MongoDB. Our cache loader, we could have a Redis configuration that we want to implement. A message broker, so a RabbitMQ, Kafka, a job queue with BoolMQ, or some middlewares that we want to run as the app initializes. What does a loader look like? Well, inside the loaders, in our express.ts here, we have our configuration for whatever the loader is. In this case, since it's Express, we would have all the request configurations that we want to handle, in this case, cores, to handle the method override, body parser, cookie parser, middleware to listen for the starter request, and our favorite, routes. This loads all of the API routes. Another example of a loader could be Kaiseli. So here we load all the configuration from our config folder, like our host, user, password, everything that we need for our Postgres DB or whatever DB that we're using. In this case, it's Kaiseli because Kaiseli talks with Postgres. The loaders is for the configuration for whatever the service or functionality that you're trying to load for the app. Lifecycle of the app, part 2. So our app is now running. We can now hit, if it's the Express loader, we can hit its route. The way this is structured is we have our index.ts in our routes folder, like I mentioned earlier here in our API. We have our routes now. Whoops, got a two head there. And here we have our grouped routes. This is so that they're separate. So all of our APIs would go here and we just pass in a router. To kind of explain a little bit more, we have this example where we mount our core routes, mount our job routes. We're passing in the router in every single one. And then we actually make a route on the router inside of these objects or functions, I guess you would say. In this case, we have a mount core routes in our routes folder, and this grouped route would be /test. So to hit, for example, this get request, which is just slash, you would do localhost 4000 or whatever your base URL. If it's in production, it would be just like google.com / whatever the route, the group is. But in this case, the base URL is localhost 4000 /API /test would get you inside of here. To hit the get, it would be just another slash on top of that and send a get request that way. And as you can see, we're finally getting into the fun part, which is the architecture of the API. Now we handle that through controllers. But before that, we have this other get endpoint that's called /Pokemon. To hit this, we would do the base URL, our test group, our route group, and then /Pokemon, hit that with a get request, and you would hit this functionality. Now, moving into the architecture for endpoints. This is a 3-layer architecture where we start from the controller, move down to the service, and then we get to data access. The TLDR of this is we keep it simple and we just separate logic out. What does this look like in real life? Let's get into it. So this is lifecycle of the app part 3. Our endpoints are now being hit. In mount core routes, we go from our little group routes, that's /test. Our controllers would look something like this, where we have a bunch of different individual controllers in our object here. In this case, it's just test controller 2, 3, 4. And what the test controller will look like is this on the right side, where it orchestrates all of the logic through services. So the controller layer orchestrates all logic through services, but it does not include any business logic. So here, we don't have any business logic. We're simply getting the user service in this case. We're calling its function and returning whatever the result is. That is how most of the controllers are structured. And that is the ideal case. We don't want absolutely any logic inside of the controllers. We only pass in and puppeteer the information to the service layer to give a little, and see, we're still here in the controller layer. Now, from the controller layer, we go into the service layer. So from our test controller in controllers, we get the user service. In this case, I'm just using a test service, but we have a test service here. This has one function called test. There's no need to have async there. I don't know why it's there. But to kind of get an overview of all this, we hit the endpoint here. We do a /test/ or even /Pokemon. Our controller, we're inside our controller, and then we call our test function here, which would be this. So we would get a console log out of that request. We hit that request, we get a console log. Our service layer expanded. So let's take a look at an actual example where we have an update user controller. In this case, we get the information from the request that is needed, and we just pass it in to the service layer. We have user ID from the request params, first name and last name from the request body, and we pass that in to the user service update user names function. And we take whatever that returns and we put it in the response. We also surround this with a try catch. If there's an error, we'll give it to the response. In our user service, we have update user names. And this uses whatever the information that was passed in from the controller to execute all of the business logic that was needed. In this case, we're updating the username. So we validate the input, check if user exists, update the user, save the user, and then return anything that we need from the user. Another example could be we have an application for like a job. We could have an application controller that calls and gets an application service. We get the job ID from the request params, everything that we need from the request body, again, pass it in to the service. And then inside of our service, we use all that information, validate the input, check if the job exists, check if applicant exists. Now, as you can see here, we're accessing the data through a repository. We could have multiple repositories, or we could have another service that does that for us. So we could have a function in another service called get user jobs. We can use that service and call it here inside of the constructor. And now we have all the functionality from that service inside of this. And we can keep calling it. So that we would be in our service layer and we would be accessing all the data from our database using either other services or a repository, but it's all basically a service. All the business logic is through the service layer. The request and the response are handled through the controller. And our data access would be all of the information that we would need from the data. And that is it. It's simple architecture that separates out all the logic from the route. You can expand upon this as much as you want. You can scale it as much as you want. You can start then looking at other files and folders like different loaders that you can go into, subscribers, but this is just focused on the endpoint architecture. Hope you found this valuable. If you did, check out the school group that I have. I'm starting this thing where I give 8 free hours into building a project of your choice. And yeah, thank you for watching. Peace.